Hey, if you're learning from home, we're going to do a quick demonstration that I showed in class learners about Pythagorean theorem that I think will help you guys too at home. Right, so we're going to be looking at a very special triangle. Right, when we're looking at a triangle, this long side is called the hypotenuse. It's always going to be the really long side of any right triangle. We know this is a right triangle because we have that corner, it's a 90-degree angle. We call 90-degree angles right angles. We know that this one is called the hypotenuse. Hypotenuse is always the long diagonal one. The other two are A and B. It really doesn't matter which one's A and B. This could be B and A or A and B. Doesn't matter as long as C is the long one, the hypotenuse. It's a fun word to use in math, hypotenuse. Now we're going to be looking at this triangle. This triangle is so special, we're going to call it ABC, that I made more copies of it, right? And they're all exactly the same. We stack on top of each other. They're all exactly the same size. And I made 4 total, so there's 4 triangles. Now there's lots of things we could do with these triangles. We can rearrange the shapes. So students were playing around and just saying like, look, we could make, how do they do it? Hold on. Technical difficulties. Right, they did stuff like this. They were looking at like this. So there's lots of different ways to arrange it. One way we looked at is we did this. We made a really cool shape. We said you could do. Right here. All right, so this is a really special shape because now we can look at the square inside that it's made. All right, let's figure out the area of this shape. This edge right here is C. We know that if this triangle is the same as this triangle, they're all the same. That means if this is C, this is also C. And I'll label that just in case you guys need to see. So this is also C, and then this is C, and that's C, because they're all the same triangle. So to find area of our triangle, it's just length times width. We would say it's just C times C. So the area of our shape is actually called C squared. Because it's just length times width, C times C makes C squared. Right, and this is so special that I actually already have this cut out for you guys. So we got C. Right, so this is C, and we're gonna set them aside now that you see that C fits inside this. So we're gonna set it aside over here. Right, now I'm gonna trace the outside because we're gonna rearrange these triangles so that it fits still in this perfect square. All right, so we're gonna move these shapes around, but it's gotta stay inside the square. Let's see, we could do, ooh, I like that it makes 2 shapes right here. Right, so we rearranged it, we stayed inside the shape, so we know that the area didn't change because we stayed within it and we didn't take any triangles out, so the area is still the same. Let's find the area of this square right here, the big one. Right, if the length here, this is A, that means this is also A. So the length is A, and if this side's A, it's the same as this one, so the height is A. To find the area of our square, we're just gonna do A times A, and we'll write that as A squared. If we want to do the same over here, we could say the height of the square is B, the length, because these are the same, is also B, and to find area, length times width would just be B squared. So now we have A squared and B squared. What we could do, since we stayed within the same area, we could say that A squared and B squared put together is the same thing as C squared. It's the same thing. So now what I'm going to do, I'm going to take our triangles away. I'm going to erase this box. Erase everything there. And we're just going to write an equation out of this. We could say that A squared plus B squared work together to make C learning from home, you might see like this is moving. This is a joke in class too. But I had to do this to get it to stay. So a squared plus b squared makes c squared. I'm going to rearrange the triangles. Hold on, I'll place my phone back down. Yes, I'm using this with my phone. Yep. All right, so we're going to rearrange it so that you guys can see it. I'll take one of my triangles. We got this guy back to our original triangle. All right, and let's place them. So we could say that the area of this guy, b squared, plus a squared is equal to c squared. Let me make sure the phone is in frame where you can see that. Yes, perfect. All right, so these two together make up this. Now, in class we were saying, yes, we could cut these up and rearrange them to fit exactly on this, and that's true. You could do that. There's some cool videos, I'll try to put it, but where you could, like you spin the triangle and it's saying if you fill this up with water, if you fill this up completely with water and you spin it, it drains into these two and fills up the exact same amount of space. Now a pretty cool example that we could practice with is saying, let's say that A is 3. And let's say, actually we'll make B 3, A is 4. Sorry, I'm recording this in a new day. I am kind of tired. All right, and this is 5. I'm going to show you how it works. All right, so if we were to square A, let's do A first. 4 squared, we would draw a square off. 4 squared is 16. All right, next let's do B. So 3 squared is equal to 9. This would be equal to the area of this one squared. 5 squared makes 25. And we know that 16 plus 9 makes 25, so it works. So this is kind of a rundown of why it works, the behinds of why it works.